Right, welcome once again to this second video on SMAR 3116. SMAR 3116. That is on shift of index of summation. Right, I think this should be the last item on their side. Right, given a series, one can sum, say, summing from n equal to 0 up to infinity, for example, of 2 to the n x to the n over n factorial is still the same as summing from some other arbitrary index, say j, from j equal to 0 up to infinity of 2 to the j x to the j over j factorial. These two are still equivalent, right? That's one thing. And sometimes it's convenient to shift your summation index, say from n to j, or vice versa. Or the most important thing is to say, given a series, is to be able to change perhaps this initial term here, and also maybe to change the powers there for convenience, as we shall encounter, right? For example, to illustrate what I'm talking about, let's look at an example here. Write the series sum from n equal to 2 up to infinity of an x to the n. Right, this series here, if I assume for convenience sake that this is my series y equal to x, you would note that my y equal to x is given by what? a2 x to the 2 plus a3 x to the 3 plus a4 x to the 4 plus on and on. But in this form, I would want to write my series as a series where I'm summing from n equal to 0 up to infinity of let me put a star there, and x to the star. So what do I have to shift my indices to, so that this new series is still equivalent to that series there, right? In fact, I can let m equal to what? To n minus 2, so that my n is equal to what? M plus 2, and then I can sum from n is equal to 2 up to infinity of n x to the n to be equal to what? To the sum from m equal to 0 up to infinity of am plus 2, and then n, that gives me what? X to the m plus 2, and I can still change this m back to an n, so that I can now sum my y of x to be equal to the sum from n equal to 0 up to infinity of an plus 2 x to the n plus 2. Notice that if I call this one maybe star here, and my top series here, or let me call this one double star, and my original series here star, these two, star and double star, they are still equivalent, but I have changed the range, sort of, to say on double star I'm summing from 0 instead of summing from 2, but the terms in this series, if I'm to expand, they are still a2 x to the 2 plus a3 x to the 3 plus on and on, which is similar to this case that we have at the top there. So this will come in handy in the solution of ODEs, where we have to shift the index of summation, right? Maybe one more example, and then right, it says write the series sum, unfortunately, sum from n equal to 2 up to infinity of n plus 2 multiplied by n plus 1 by an by x minus x naught to the power n minus 2. Right, so solution, okay, it says write this as a series whose generic term is x minus x naught to the power n instead of n minus 2. So I can let m, my dummy variable, be equal to what? To n minus 2. This implies and is implied by the fact that my n will be equal to what? To m plus 2. And clearly, I can now sum from m equal to 0 up to infinity and substitute every n with m plus 2, so that I've got m plus 2 for this term multiplied by m plus 1. In fact, this must be m plus 2 plus 1 by a what's n? N is equal to what? M plus 2. So this becomes m plus 2 by what? By x minus x naught to the power m. Right. And simplifying this gives me a sum from m equal to 0 up to infinity of m plus 4 into m plus 3 by a m plus 2 by x minus x naught to the power m. And I can, without loss of any generality, I can change my index from m back to n, so that I can rewrite this as the sum from n equal to 0 now up to infinity of n plus 4 by n plus 3 by a n plus 2 x minus x naught to the power m. Note that these two, this one here, this series is still equivalent to my original series here. Still equivalent to that there. So right, so there are two things perhaps that may influence the change of your index. Is either you want to write the term in x in a particular form, like for my second example here, we're told that express the series in terms of x minus x naught to the power n instead of the original x minus x naught to the power n minus 2. This is one reason why you may want to shift, or you may want to start summing from the same index. That is, you would want to sum everything, say from n equal to 0 up to infinity of your an x minus x naught to the power n. Right. I think given that should be enough for this topic. Thank you.